Welcome, Hornets. Tonight we're going to be talking about finding the equations of tangent lines from any function that we have that we already know is continuous and smooth. So let's just remind ourselves. We're talking about differentiable functions, and differentiable functions have two criteria. The first is continuous, or having continuity, and those three criteria come from the definition. And they state that the limit as x approaches a for the function f of x exists. This is for all values of a in the domain. The second is that f of a exists for all values of a in the domain. And the third is that the limit as x approaches a for f of x must equal f of a. Now, the second criteria is that idea of smooth. And the idea of smooth is now saying that the limit as x approaches c from the right and we use the alternative form. You can use the difference quotient if you prefer. You can use delta x or h. But I'm going to use my x minus f of c all over x minus c has to equal the limit from the left. So we got the right, so let's put in the left. The limit as x approaches c from the left for f of x minus f of c all over x minus c. So these are our two criteria, continuous and smooth. Smooth is that idea of no sharp turn, jagged edge, corner, anything you want. If we can form a vertice, we probably are going to have a problem. So keep in mind, vertices are places where we're going to have two slopes at the point of tangency. Okay, so let's take a look at a function here. We're going to take a look at f of x at x squared minus 6x. There's our function. We're going to look at the specific point 5, negative 13. Now, in order to do this, it's actually quite straightforward. We need to take the derivative, d dx, of our function f of x, which is the same thing as taking the d dx of x squared minus 6x. Now, this gives me f prime of x, or if you prefer, you can call it df of x, dx. I don't care. Either way, it's still going to be our derivative, 2x minus 6, and we're evaluating it at x equals 5. You'll notice we're going to end up having negative 4, positive 4. Okay, let's just make sure you see that. Well, this is the slope of the tangent line going through the point 5, negative 13. So what we're talking about is a parabola. Parabola is going up like that. There is some point, and that point is 5, negative 13. And what do we know? The slope of that tangent line is 4. Well, that means that the tangent line, written in point slope form, is y plus 13 equals 5 times 4. Or let me rewrite that as mx plus b. So I'm going to put my 4x, and let's put slope minus 5. There we go. Now we have our point slope form. Now if we were to try to do this, we'd have y equals 4x minus 20, right? And then we would have a minus 13 to boot. So we could have the equation of the tangent line written in this form, or potentially 4x minus y minus 33 equals 0. All of these are equations of the tangent line. And it is up to you which of these three forms you're going to use, but I'll be honest, I prefer that one right there. So notice, finding the equation of a tangent line given a point and an equation. Okay. Once again, we know this is a differentiable function because it is quadratic. Quadratics have no discontinuities. There are no sharp turns. We can take our derivative from the left will equal the derivative from the right. So it is smooth. All righty. Thank you very much. Take care, Hornets. Be well, be safe. Have a good evening.